Computer manufacturing refers to the process of creating the physical devices that run software and store data. This involves various stages, including sourcing raw materials, assembling components, and testing final products. These processes are complex, not only due to the nature of the technology itself, but also due to the environmental impact of the materials and energy used in this process. An example of the environmental impact of computer manufacturing is the use of rare earth elements. These materials are crucial for making components such as screens, magnets, and batteries. Mining these elements often causes significant environmental harm, including soil erosion and water contamination, which negatively affects nearby ecosystems and human communities. This topic relates to sustainability, as it demands careful consideration of how resources are used and reused. It also connects to environmental issues, because many different stages in the production process can lead to pollution and waste. In the realm of information technology, manufacturing underlies all other aspects of computing, since it impacts the availability and performance of the digital devices that are central to modern life around the world. The social impact of computer manufacturing is evident in practices such as electronic material recovery. Take, for example, activities in Thailand, where communities in Bangkok's outskirts process discarded electronics to extract valuable metals. While this labor creates income opportunities for workers, it often occurs in informal settings with minimal safety oversight, leading to health risks from exposure to toxic chemicals and localized soil contamination. This situation highlights the need for better systems that balance economic opportunities with environmental and human well-being. Considering the interplay between technology manufacturing and natural systems brings attention to three main areas. First, sustainable design encourages the development of devices that can be repaired or reused rather than discarded. Second, sustainable economies highlight how production processes could shift away from linear models of take, make, dispose towards circular methods that prioritize reintegration of materials. Third, conservation biology emphasizes the importance of safeguarding habitats from pollution that originates from manufacturing practices. Together, these ideas suggest a path where manufacturing aligns more with sustainable and ethical principles.